Hi everyone, this is Mrs. Trigno, and this very short video will cover problems 33 and 34 from the first packet of your Algebra 1B first semester exam review. Okay, problem number 33. I want you to write an equation for a line passing through two coordinates, 2, 5 and 8, -7. Okay? I would suggest that anytime you are asked to write the equation for a line, no matter what other information you are given, no matter what form you are writing it in, I would start by doing whatever you can to find the slope if it's not given to you. Because no matter what formula you're using for one of these lines, you're going to need to know the slope. Probably many of you remember the formula for slope when you have two coordinates. It is y2 minus y1 over x2 minus x1. And by the way, that formula will be provided for you on your formula sheet for the exam. And what this is really saying is I want to take the y coordinate from the second ordered pair and subtract the y coordinate from the first ordered pair. So that would look like this. My y2 value is -7 because it's the y coordinate in the second ordered pair minus the y coordinate from the first ordered pair, which is 5. And then same thing with the x values. x2 would be 8 and x1 would be 2. So -7 minus 5 over 8 minus 2. Well, -7 minus 5 is -12, and 8 minus 2 is +6, and then -12 over 6 is -2. That means that your slope, which remember we designate with the letter M, is -2. Okay, that's the first step in writing this equation, is just finding the slope. Now, because I'm not given a y-intercept here, I'm stuck having to use what's called point-slope form. And point-slope form looks like this. Y minus y1 equals m times x minus x1. Okay? And again, that formula will also be provided for you on the formula sheet. What we just found was the slope, and like I just said, slope is always represented by the letter m. So I know that this -2 I just found is going to go right here. The only other numbers I have to fill in here to this formula are y1 and x1. And those just represent the coordinates of one of the points on this line. So I can choose to use either one of the coordinates, 2, 5, or I could use 8, -7. What I can't do is mix and match, so I have to choose either the first two or the last two. And probably because the first two don't have any negatives in them, I would stick with those ones. So x1 is 2, and that's going to go in this spot. And y1 is 5. That's going to go in this spot. And then the biggest mistake I see with this type of problem is students wanting to fill in the x and the y. Remember that when you're writing an equation for a when you're writing an equation for a line, there's always going to be an x and a y in your problem because that represents the other coordinates on the line. So we are not filling anything in for the y or the x. We are only filling in numbers for y1 and x1. That means that once I've got these three numbers into place, I'm really just bringing down the rest of the equation. Y minus 5 equals -2, parenthesis, x minus 2. Okay. Now technically I could stop here because all this is asking for is an equation. And this is an equation. It has an equal sign in it and it has my x and my y. However, I'm going to go ahead and show you how to simplify this just so you know how to do it if you do happen to encounter that. First thing I would do to simplify this is distribute this -2. So that would leave me with y minus 5 equals -2x plus 4. And then I would move this 5 over to the other side. Now I'm running a little bit short on space here, but to move a -5 from one side of the equation to the other, remember I would add 5 to each side. So that 5 would combine with the 4 that I have over here already and become a +9. Okay, so all I did there was add 5 here and here. That canceled that 5 out, and I ended up with 9 over there. And now my equation reads y equals negative 2x plus 9. Notice that's now slope-intercept form. So you can start with point-slope form and then convert to slope-intercept form. Okay. Problem number 34 is very similar. Okay. Again, it's asking for an equation of a line passing through 0, negative 3, and 4, 9. So the first thing I would do is calculate the slope. y2 minus y1 over x2 minus x1. So y2 would be 9. y1 would be negative 3. Be careful here. That means you're really doing 9 minus negative 3. Okay? Which many of you know would really just turn into a 9 plus 3. Okay? If you're subtracting a negative, it's same as addition. And then on the bottom, I would do x2 minus x1. So 4 minus 0. So this ends up being 9 plus 3, which is 12, over 4 minus 0, which is 4, and then that simplifies down to just 3. So my m value, or my slope, is now 3. Okay? Now I'm going to move over here and use that same point-slope form that I used on the previous page. And again, that reads y minus y1 equals m times x minus x1. Okay, I'm going to fill that 3 in for m, because what we just found was the slope, and that's represented by the m. And remember, the only other numbers I fill in are y1 and x1, and I can choose either one of my coordinates to work with here. Okay, I'm going to choose the first coordinate again. Not because you always have to choose the first coordinate, but I like this one because it has a 0 in it, and zeros are really easy to work with. So that 0 actually goes in for x1, and the negative 3 goes in for y1. Okay. Something to be careful of here when you bring down the rest of your numbers. This is a negative 3, but there is also a minus sign in this problem. That means really what you're doing is y minus negative 3, which hopefully by now you've caught on that that would really be y plus 3. Doing y minus negative 3 is the same thing as doing y plus 3. Equals 3, and then in parentheses I would have x minus 0. Now here's why I said zeros are really nice, because x minus 0 is really just x. Okay, there's nothing else you have to do with that. So what this is really saying is y plus 3 is equal to 3x. Okay, because again, x minus 0 is just the same as x. So this is really just saying 3 times x. And then the last thing I would probably do here is subtract this 3 from each side. Remember, I can't combine that 3 with that 3x because they're not like terms. So I would just be stuck writing it as 3x minus 3. And that's the end of the road. That's where I would leave that problem. Okay, a quick word on problem number 35. Problem number 35 is a scatter plot. And the scatter plot piece of it you would have to do by hand. Okay? Which means that you would want to label your years along the x-axis and your life expectancies along the y-axis. And remember, you are not just listing the numbers that are given to you in the table. You would actually have to count by a consistent number. So, for example, you might want to start your years at 1950 and I believe maybe count by 5s or 10s to get to at least 2007 by the end of your graph. Okay? That piece of it you would do by hand, then plot each point individually. Parts B and C here, though, for the line of regression and the correlation coefficient, do require a graphing calculator. I don't have a graphing calculator here at home with me, so I will not be doing this problem here on this video, but I will post a new video tomorrow explaining just how to do problem number 35, and I will show you all of the steps on the graphing calculator. But that should at least point you in the right direction for part A, for constructing your scatter plot. Okay? Other than that, that does it for your first packet. That is half of the material that is on your first semester exam. That covers chapters 1 through 3. The next packet will cover chapters 5 and 6, and those videos will be posted shortly. Thanks for watching.